Hi guys, in this video we're going to learn about the auto-ionization of water, pH, pOH, hydrogen ion concentration, and hydroxide ion concentration of solutions. Remember I told you all yesterday that water was amphoteric, that it could be considered as either an acid or a base. And if you remember, we had water, HOH, and we had it dissociating into hydrogen ions plus hydroxide ions. Okay, now let's take a look at the equilibrium expression for water. The equilibrium expression for water, which is Kw, and you can also call this the ionization product constant, or the dissociation constant for water. Kw will equal the concentration of a hydrogen ion times the concentration of the hydroxide ion. And both of these combined together, when they multiply together, they'll end up being 1.0 times 10 to the negative 14. So now, let me break that down for you. So in other words, for Kw, you will have would equal the concentration for my hydrogen ion concentration times my hydroxide ion concentration to equal 114, 1.0 times 10 to the negative 14. Your hydrogen ion concentration would be 1.0 times 10 to the negative 7. The hydroxide ion concentration will be 1.0 times 10 to the negative 7. Multiply these two together. That is how you get the 1.0 times 10 to the negative 14. So what we're saying is the concentration in a neutral solution, the concentration of hydrogen ion equals the concentration of hydroxide ion, because you see that both of them are equal to 1.0 times 10 to the negative 7. And when multiplied together, they equal 1.0 times 10 to the negative 14. So now, in a solution, if the hydrogen ion concentration is greater than the hydroxide ion concentration, then your solution is acidic. If your hydroxide ion concentration is greater than your hydrogen ion concentration, then your solution will be what? That's right, basic. Now, if your hydroxide ion concentration is equal to your hydrogen ion concentration, then the solution will be neutral. Okay? So now, what we need to understand, and in both your books, because you're looking at the Zumdahl book and the Brown-LeMay book, guys, in both your books, sometimes they treat hydrogen ion and hydronium ion concentration interchangeably. So we can easily say that Kw is equal to the hydrogen ion concentration times the hydroxide ion concentration, that's a negative. Or you could say the hydronium ion concentration, which is a protonated water, remember, times the hydroxide ion concentration. All of these, both of these will equal Kw, and we already know the value for these will be 1.0 times 10 to the negative 14. Now guys, what you need to understand is that the acidity of a solution is expressed either as the molar hydrogen ion concentration, which is the concentration of hydrogen ion, or is expressed by the pH. So now, what I want to introduce to you now is pH. Again, what I just stated was the pH deals with the acidity of a solution. So now, The equations that you need to be familiar with the pH. pH is equal to the negative log of the hydrogen ion concentration. That is the equation for pH. All right? What you also need to know is that pH plus pOH, this will be for an acid, this will be for a base. Notice the hydrogen, notice the OH for base. pH plus pOH is equal to 14. All right? Now, there is something called a pH scale. Now, on the pH scale, 7 is neutral. Okay? Now, anything less than 7 is acidic. Again, anything less than 7 is acidic. All right? Anything greater than 7 will be considered basic. So again, if you get a pH, anything meaning a pH, any solution less than 7 will be the pH. If this pH is less than 7, it will be considered acidic. Any solution that's less than 7, the pH is greater than 7, it will be considered basic. So let me say that one more time. Any solution with a pH of less than 7, the solution will be rendered acidic. Any solution with a pH of greater than 7, the solution will be rendered basic. Now, what I want to do right now is I want to give you a problem, and we're going to see how we're going to calculate calculate the pH of a solution. So now, what I want to do is I want to give you a problem, and in this problem, you're going to determine the hydroxide ion concentration, the pH, and pOH of a solution that has a concentration, has a hydrogen ion concentration of 2.3 times 10 to the negative 4. So again, we're going to calculate the hydroxide ion concentration, the pH and pOH of a solution that has a hydrogen ion concentration of 2.3 times 10 to the negative 4. All right? First things first. Remember up here when I told you that Kw for the hydrogen ion concentration times the hydroxide ion concentration is equal to 1.0 times 10 to the negative 14? Well, we're going to use that in order to find the hydroxide ion concentration. So now, remember, Kw is equal to the hydrogen ion concentration times the hydroxide ion concentration, and that's 1.0 times 10 to the negative 14. So now, let's take a look and see how I'm going to apply that to this reaction here. So now, first, we have, if we go ahead and put this in, we already know the hydrogen ion concentration that I have is 2.3 times 10 to the negative 4. So now, therefore, using this reaction here, or this equation, the hydroxide ion concentration is going to equal to Kw over the hydrogen ion concentration. And in this problem here, my Kw is 1.0 times 10 to the negative 14. My hydrogen ion concentration we have is 2.3 times 10 to the negative 4. So therefore, my answer is going to be 4.3 times 10 to the negative 4. That will be my hydroxide ion concentration. Now, let's take a look and see how would I find the pH. Now remember, pH is equal to the negative log of the hydrogen ion concentration. Now, our hydrogen ion concentration is this instance. This is the negative log of, what we get up here in this problem, 2.3 times 10 to the negative 4. So pH equals a negative log of 2.3 times 10 to the negative 4. Plug that into my calculator, and I end up with 3.64. Now, remember, I told you up here, pOH plus pH equals 14. Remember, I told you that. So therefore, if I want to find the pOH would equal 14 minus the pH. We just found out that the pH was 3.6 right here. 3.6 times 10 to the 4, 3.64. That's the pH. So therefore, the pOH will be 14 minus the pH, which is 3.64. So my pOH is equal to 10.36. Okay? So, again, what we just learned through this lesson, we learned about the autoionization of water, the equilibrium expression for the water, which is Kw equals the concentration of our hydrogen ion times the concentration of hydroxide ion, which is 1.0 times 10 to the negative 14. And we know that the hydrogen ion concentration is equal to the hydroxide ion concentration, which is 1.0 times 10 to the negative 7. This is with water. Okay, this is what makes water neutral. Then we talked about if the hydrogen ion concentration is greater than the hydroxide ion concentration, solution is acidic. If the hydroxide ion concentration is greater than the hydrogen ion concentration, the solution is basic. And if they are equal to each other, then we know the solution is neutral. Then we went on to talk about pH. Remember, the acidity of a solution is determined by either the hydrogen ion concentration or the pH. That is what the acidity of a solution is measured by. So then we have pH equals a negative log of the hydrogen ion concentration. And we have pH plus pOH is equal to 14. We talked about the pH scale. For the pH scale ranges from 1 to 14. pH scale ranges from 1 to 14. So now, pH of 7 is neutral. Anything less than 7 is acidic. Anything with a pH of greater than 7 is basic. Then we solve for a problem. In our problem here, we determine the hydroxide ion concentration, pH, pOH of a solution that had a hydrogen ion concentration of 2.3 times 10 to the negative 4. Then we solve for the problem. We solve for the hydroxide ion concentration using our equilibrium expression for water. Then we solve for the pH with the hydrogen ion concentration, and then we solve for our pOH. What I want you to do right now, I want you to do the problems in Zoom Doll, chapter